Problem number 5. Problem number 5. Two particles are projected from the same point with the same speed u such that they have the same range r but different maximum heights h1 and h2. Which of the following is correct? So, two projectiles are thrown, two particles are projected with same speed, initial velocity is same, both are u, and they have same range r. We know that the formula of range is capital R is u square sine 2 theta by g. What is u? U is the initial velocity and theta is the initial angle made by the initial velocity with the horizontal. So the projectiles are thrown with same initial speed. It is that u is same for both the projectile. So in order to equal range, the theta should be theta and 90 degree minus theta. For these two angle, range will be the same. Why? Let's put this value. Let's say first projectile range is r1, so this gives us sine square u square sine 2 theta by g, and for second projectile, let's say range is r2, then r2 also gives us u square sine 90 degree, sine 2 into 90 degree minus theta by g. So this gives us sine 180 degree minus 2 theta by g. So this will be again sine 180 degree. It will be gives us sine, and second quadrant, and the value of second quadrant is sine. The value of sine is positive. So this will gives us u square sine 2 theta by g. So for the angle theta and 90 degree minus theta, the range is same for both the projectile. So we assume that for first projectile the angle is theta, and for the second projectile the angle is for first projectile, and for the second projectile the angle is 90 degree minus theta. So let's calculate what is the maximum height heights reached by these two projectiles. This is the maximum height h. And how can we calculate the maximum height h? The maximum height h is v square is equal to u square minus 2 as. It is that for maximum height v, it is that final velocity is 0, so it is 0 square. U will be the vertical initial velocity along vertical. It is that u sine theta, so u square sine square theta minus 2g, and the maximum height is h. So h gives us u square sine square theta by 2g. This is the value of maximum height h. So we use this formula. So for first projectile maximum height, it is that h1 gives us u square sine square theta by 2g. And for second projectile the maximum height is h2. And how can you calculate it? U square, and now the angle is 90 degree minus theta, so this is sine square 90 degree minus theta by g. So this gives us u square cos square theta by g. So this is the value of h1 and h2. We can calculate this. So we multiply h1 and h2. What this gives us? U to the power 4 sine square theta cos square theta by g. So let's play some mathematical calculation. We know that 2 sin theta cos theta gives us sin 2 theta. So we take u to the power 4 2 sin theta cos theta and whole square. So this gives us u to the power 4 sin square 2 theta by g. We can write it as u square sin 2 theta by 4g by square. H1 is 2 gives us h1 is 2g and h1 is 2g and this gives us also 2g. Here we miscalculation. H1 is u square sin square theta by 2g and h2 is u square cos square theta by 2g. So after multiplication this gives us 14. So this will be 16. So this is 16 g square. So this is g square. So that is 4g whole square, or let's g, and this is g and this is gives whole square. So this is the value e square sin 2 theta by g. This is the value of range R. So what we can get? We can get here. So what is the value of R? We calculate it is at u square sin 2 theta by g. So after multiplying h1 h2 this gives us u square sin square 2 theta by 16 g square, and we write it as 1 by 16 u sin u to the power 4. This is u to the power 4 square sin 2 theta by g, and this is whole square. So this gives us RA square. So R square will be 16 h1 h2. So the answer is B. Thank you.